How fast can I explain Newton's 3 laws of motion? Let's find out. So Newton's laws of motion deal with forces, and forces are generally measured in newtons. Now Newton's first law says that if an object is at rest or at a constant speed, it will remain that way until acted on by an external force. A very basic example of this would be a box resting on top of a table, because that box has a certain weight and it's weighing the table down. This is your weight force and it points in the negative y direction vertically. But the table is going to exert an equal and opposite force back up on the box. If the force exerted upward vector here was bigger than the smaller one, that would imply that this box is being lifted off the table, which we know in this case is not happening here. Now, if this downward vector was bigger, this would imply that the box here is breaking through the table and that the box is falling through it. Neither one of those are happening, so we can see that the two vectors are equal, meaning that the box is at rest because the two vectors will cancel, meaning there's no net vertical force acting on the box. Now notice also that there's no horizontal forces, so the box right now will be at rest as stated by Newton's first law. But what if we apply an external force? Let's say that you take your hand and you push the box to the right. Now the box is going to be moving in the positive x direction. But if someone else were to take their hand and apply an equal force to the left, that would actually cancel out with the amount of force that you're applying to the box, meaning that the box would once again be at rest. Now let's say that you take a different box and you slide it with an initial velocity across the floor. It's going to move at a constant speed. That's what happens when you slide a box. Well, the thing that's going to stop that box from sliding or slow it down are going to be external forces. An example could be if you put your hand down and forced it in the other direction. Another example could be if it runs into a wall, or a very simple example is if friction is forcing the box back, because friction is an opposing force, so that's going to cause the box to stop sliding eventually. Now let's talk about Newton's second law, which is force is equal to the product of mass and acceleration. This can be used to calculate many situations that involve force, such as trying to calculate the acceleration of a tractor pushing a 100 kilogram boulder with a force of 500 newtons. So the way you could calculate this is by using equation. You could plug in your 500 newtons for force and your 100 kilograms for mass. You divide both sides by 100, you get the 100s to cancel, and you'll have that acceleration is equal to 5 meters per second squared. This is the general unit here for acceleration. Now Newton's third law says that for every action there's an equal and opposite reaction. Now let's look at an applicable example of Newton's third law, where you take some sort of ball and you throw it in this trajectory in the positive x direction. Now what's going to happen is that ball is actually going to push you backwards with the same amount of force. Now let's just say here you're on a skateboard and there's no friction on the ground. Well, just imagine there's no friction here. Even though the forces are going to be the same in both directions, the accelerations are not going to be the same. The ball is going to accelerate much faster than you're going to accelerate backwards. And why is that? Well, the answer is mass. Your mass is much greater than the mass of the ball. So therefore the ball is going to accelerate much more than you are. Acceleration is equal to force over mass. Now notice something. Acceleration is inversely proportional to mass because mass is on bottom of the fraction. That means as your mass is smaller, your acceleration is bigger. And as your mass is bigger, your acceleration is smaller. Notice that every time the denominator is small, the total fraction is bigger, but when the denominator is bigger, the total fraction is smaller. That was a general introduction to Newton's 3 laws of motion.